So I hope you found that actually interesting, this chaos theory and this introduction. If you want to know more about chaos theory, I have some suggestions where you can start reading further. Start with Wikipedia, chaos theory. Wikipedia gives a very good introduction. The second recommended here is actually an article, it's like 10 or 15 pages PDF. And this is interesting because it explains actually why physicists are actually they don't like chaos theory. I mean, before people had they thought if you have physics, you can determine, your initial condition, you can calculate what's going to happen, so everything is predictable, and you have a nice analytical theory that predicts reality. And now comes chaos theory. First comes quantum mechanics that tells you, first of all, that you can't really know what's going to happen, really. But even in the classical, it now even shows that chaos theory shows that even classical deterministic systems are highly unpredictable. And that's, of course, many people didn't like that. And therefore, that's also one of the reasons, perhaps, why where we learn too little about it, actually, even as engineers. Because people are a bit hesitate to take this unpredictability and understand that reality is unpredictable. Another two examples where you can do reading. This is a very nice example of how a fractal is built up. The third one here is a YouTube movie. And the fourth one is a BBC movie where chaos theory is actually expanded into what it means in terms of psychology. So, of course, chaos theory is not only important in physics, it's important in things like evolution, biology, economics. The stock market is highly chaotic. But, mathematically predictable chaotic somehow, Weather forecasting, that's where it all started, actually in the 60s. Another reason, I think they explain that also in the video, the reason why this is a novel theory is that we only stumbled upon it because we can do very precise calculations using computing now. And it's only when we do all this calculation that we see that very small changes in initial conditions lead to huge differences. That is actually everywhere. All right, but where does it come into microfluidics? Well, we're going to use it for mixing and chaotic mixing. So what is a chaotic flow system? Chaotic flow system is a system where, for example, I have a flow duct and I have a flow in this direction. And if I have a chaotic flow, that means that if I have, for example, a little fluid element in this position here, it will move to this tube in a certain manner. And if I consider another fluid element that I can put very, very, very close to the first one here, and I follow it, I will see in the beginning it kind of moves similarly, but very rapidly it starts changing its trajectory in a totally different way than this one. So within a finite amount of time, I will get an exponential growth of the distance here between these particles. This exponential growth, by the way, is called, the exponent of that is called the Lyapunov exponent, if this is something. So if you have studied any chaos theory, this is an important concept, the Lyapunov exponent. And so if I have a chaotic flow pattern, I will see that two particles that are initially close to each other, within a very short time are in very different positions. So